Okay, now we'll start understanding the cantilever beam. Please try to guess what I'm drawing. Aeroplane. Okay. An aeroplane. Guys, here if you want to understand, you know that this aeroplane can be like several hundred tons. 1 ton is 1000 kgs. Aeroplanes can go in terms of several hundred tons, like many trucks, 50 to 60 trucks maybe, and that flies. So that weight is being lifted by the wings. The wings lift the weight, and of course, that's from the side view. The aeroplane may look like this, somewhat like this. The aeroplane may look like a tube, like something like this, and you will have this huge wings here, which is very difficult to be shown in this angle because it comes perpendicular to you. It almost comes like this, and here you'll have an engine, something like this. Here you'll have seats, you'll have the windows throughout, something like this. Okay, so you know that there is weight throughout the plane. There is weight throughout the plane here, and to balance that, now imagine that if I have to balance this book here, where I have to hold? At the center. So that means this aeroplane is applied with loads at every point. And here you need to find a center here, which is the center of the weight. So center of the weight, you need to apply a pressure from bottom. So that means this wings should be placed somewhere there, and also this ailerons should actually act in such a way that they balance the moments. Otherwise, the center of gravity may be somewhere other than the center of the pressure here. The aeroplane can actually have this pitching effect. Okay. Of course, this is mechanics of materials. We are not aeronautical students, we are automobile students. Okay. But still, I'm saying that there's so much of weight acting downwards here because of this fuselage, and these wings are trying to lift it upwards. Okay, so basically, if you see throughout, you'll see that there are so much of loads which are being applied upwards. And if you see the shear force here, guys, now will this engine, of course this engine weight tries to apply a small amount of force bottom here, because the engine may be around maybe 5000 to 6000 kgs alone. Okay, and then a huge engine, and there will be pressure here. The lift force from throughout the wing, and one force here, and this. And if you see this here, the same shear force diagram can be drawn. The shear force diagram can be then drawn. Suppose if you see here, what is the shear force at this point? 0, no shear force. And what is the shear force here? Now what is the convention? Downwards is positive, upwards is negative. It starts increasing like this. At some point you have this engine load. Again it starts decreasing here. Again you have got this weight of the fuselage, again going upwards, something like this. So you'll almost say that there's a huge amount of shear force at this point. And also if you see the bending here, suppose if you are trying to draw a bending moment diagram, at this point here, then what will be the bending moment diagram, guys? Now will this bending moment be positive or negative? Anything going upwards is positive. Okay, so here you see that there is throughout forces going upwards. It is positive. Okay, it starts increasing. At some point, again you won't decrease, but again you'll see that the rate at which it decreased starts increasing here like this and it decreasing like this. Okay, so you can see that at this point you will have a huge amount of shear force and huge amount of bending moment. So what you have to do, you will have to make this structure very stiff at this point. Okay, now it is almost like your arm. Your arms are bigger at this point because you need to carry the bending moments. Okay, something like that. Okay, even if you see a tree, so I think nature is the best designer. And if you see a tree like this, it is the stem. If you got a horizontal branch, the branches will be very thick and it starts thinning out. And you will have branches like this, Suppose if you have a horizontal branch, something like this, then you will have this branches like this. You will have small branches here going like this. You will have all leaves. Okay, so here at this point where there is so much of shear force and bending moment, the branches became thick. So that means suppose if it was ulta, branches were very thin and it became larger here. So can you imagine what would happen? Then I think these trees wouldn't have sustained. I think they have designed themselves to take huge amount of bending moments. The branches are very thick at this point where they are actually supported here. So this is like almost the cantilever. So cantilever, as you see in the diagrams, so you see that there is a overhang, it is like a cantilever, and sometimes, so cantilevers come out of a fixed point like this. We call this as a cantilever. Usually people think of a cantilever as a fixed beam like this. Okay, and if you don't see the fuselage, if you only see this, it is the same as this. The fuselage is here. It is like a cantilever. But in this case, I think the forces are upwards. But usually in most of the cases, suppose if there is load acting on this, then it will be downwards. So cantilevers are where there are no supports at the ends, and these moments are balanced by a moment here and also a shear force here. So that is cantilever. We will try to solve a numerical on the cantilever now.